I almost wiped my entire production database and I didn't even write the code that did it. My AI did. I have been building these autonomous AI assistants that run my entire business. My courses, my SaaS apps, this YouTube channel, and everything else I need in my business. I want them to think on their own, fetch data, and trigger workflows, all without me having to interfere. And it was going great until one of my agents hallucinated and it literally tried to nuke my production tables. Luckily for me, I review everything that the agent does, but it was a close call. But here's the truth. I don't want to monitor every single thing that the agent does. I want to just assign tasks and I want them to think, act on their own, and trigger workflows. So after that, I have revisited my entire architecture, burned everything to the ground, and built it back up piece by piece. Today, I want to show you exactly how I built these AI minions, my updated architecture, what broke, and how I nearly lost everything. So if you want to ship your own AI agents instead of hiring folks, watch this video so you learn exactly how to add those guardrails in place. But more importantly, I'm going to show you how I put these AI agents on an absolute leash so they can never cross the line. So let's get into it. And a huge shout out to Supabase for kindly sponsoring this video. So quick context, I run an education business. I have courses. I work with different sponsors on my channel, such as the sponsor for this video, Supabase, that helps support the channel. I also have a newsletter. On top of that, I have spent over a decade as a senior engineer before I went full-time running my own business a couple years ago. For the last few months, I've been obsessed with building agents that run my business for me instead of hiring a bunch of folks. So before we get started into the architecture and dive more into code a bit later, I want to describe what an AI minion is according to me so that we are on the same page. Now, in the movies, there are these little chaotic helpers that do stuff for you, sometimes brilliantly, sometimes terribly, and that's what we're building. The real definition for AI minions is that it's an autonomous agent embedded in your app that can reason, fetch data, trigger actions, and make decisions on their own. And this is the important part, making decisions on their own, which is exactly why I want to build a bunch of AI minions that can run my business for me. In reality, this is what we want, right? And I understand what you're thinking when you think of autonomous AI agents. You may think that autonomous means uncontrolled, right? But it does not necessarily mean uncontrolled. It means that we are going to draw the lines and the agents are going to stay in the parameters that we set specifically. It means that the agents can make decisions inside a box, but they cannot do things or have permissions that we don't want them to have. And it's honestly really fun to be building these agents further. So for example, in my case, as the agent, my entire production database, the lines were drawn wrong. So I had to redefine them, redraw them so that agents knew exactly what they can or can't do. So now that we understand what an AI minion is, let's go over the architecture a little bit and figure out, okay, these are the tasks that I have and how could I go from there? Now, 4 things make an agent an agent. The first one is context. So it knows exactly what's going on. The second one is memory, so that it remembers exactly what happened before. And I will show you exactly how we added memory to the system that I have. Tools, for example, the actual functions it can call, what it can or can't do. So if you give access to everything, it's going to go crazy. The brain of the agent, the model that actually does the reasoning. So if you can picture all of these, or I guess the API too, wherein you are calling a lot of these services. And going back to tools, tools could be searching the web, reading or writing files, accessing your database, like whatever it might be. So if you can picture these 4 pieces, you can build an agent, essentially. Context, memory, tools, and a brain equals agent. Now, in terms of building my agent, or what I'm building, first of all, these are example of few AI agents that I have specifically built. One is a communication copilot for someone to manage my inbox, someone to monitor my site and fix issues. Next.js can get really outdated. I have a course called Next.js.dev that helps you ship production-ready applications. You can check it out. The link is in the description. But as you know, every time there's a new update, things break, things get outdated. I want a way to automatically monitor that. So that's also one of the things that the agent can do. A content auditor agent that checks my course against the latest Next.js release and tells me where the gaps might be. That has been a very helpful agent in general. So let's go with the architecture here in terms of how I architected it. First of all, I'm using Telegram. I've also tried using WhatsApp, but for some reason it has been unreliable. Telegram has been amazing to get it set up. Then if a user messages hi, then this is exactly what happens. I have a logging layer where I log every single thing that the agent does. This way it can always trace back and figure out exactly where it went wrong, where it went right. Is it doing the right thing, or do I need to add more guardrails in place? So logging is extremely important. Second is conversation persistent, so that every agent, essentially whatever it does, if I ask a question, whatever, it gets translated into a step in the database. This is the same chat ID, but you can see exactly everything that the agent is doing over here. So these logs really help a lot. Then I also store conversations, so any type of conversations occur. Now, obviously, this is not my actual database because I don't want to show you my data, my personal data, but I've tried to replicate it so that you know exactly how it works. So how many sales this month, and whatever the messages are, it's going to log that over here so that I could always trace back to. And then certain agents need an approval as well. We'll get to that in a second. But lastly, we have the agentic loop. Everyone talks about this agentic loop. It's like it's some sort of like a magical black box. It's essentially just a while loop. When a model says, I need to call a specific tool that is a specific task, in my case, it will be checking my code base to see what the discrepancies are in terms of versions, checking the Next.js docs to see what new updates have come up. So they call the tool and you feed the result back, and the model decides if it needs another tool or not, or if it's already done. So you already know how to write this because you've been writing while loops your entire career. So this is something that I would say is the biggest misconception, or like it makes things very tricky when you're shipping agents. So let's say we have a query, is my course content up to date? Then this is what's going to happen. We check again in natural language on Telegram, no commands, nothing, no buttons to click. And then that's where, like I mentioned, a Telegram bot will have a webhook that we will see very soon. And then right after that, Claude Anthropic Agent SDK is going to automatically pick the right tool. We are going to be giving access to a variety of different tools that this specific agent can access. A few of them are refund student, adding student, checking course freshness, and so on. Checking course freshness. As Claude says, hey, the right tool is check course freshness. That course freshness then has a separate prompt that will essentially do the job. It will gather live data. It will look at package.json, GitHub Canary, Next.js blog, courses. I've given it access to all my lesson files, so that's exactly what it's going to check. For that, it's also going to need file system reads and a live fetch, that means web search tool as well. And lastly, it is going to compare the teaching, what I'm teaching, and what's reality, and then make those changes, not just create a vague summary, but actually summarize and send me a message in Telegram automatically, so the reply lands on my phone. Here's the tech stack that I use. I'm using Next.js. I'm using the Next.js API routes for webhooks and to write the overall code. I'm also using the Agent SDK from Claude, from Anthropic, because it not only autonomously read files and run commands, it can also search the web, edit the code, and so much more. Agent SDK gives us the same tools and agent loop and context management that powers Claude Core, which is very important and why I've chose the Agent SDK. I also did use a couple of other agent SDKs in the past. However, I felt like this Claude Core Agent SDK was way powerful compared to the other options that I've tried with. So that's what I went for. Plus, it has really good documentation on what you can or cannot do, what tools to give access to, and so on, which we'll take a look at very soon. These are all the different allowed tools, permission modes. Again, if you're used to Claude Code, this will feel right at home for you because that's how my brain works as well. All the data is in fact stored inside Supabase. The reason why I went with Supabase is because it has been an incredible partner when it comes to shipping AI agents. As you know, on this channel, I have tried a variety of different databases, but for agentic tasks, I've stuck with Supabase because it just aligns with my thinking. It aligns with how I want to build agents. Adding security layers to my database, which I'm going to show you, is also done very easily inside of Supabase so that my agent can just focus on shipping it without having to delete my production data as well. So the entry point is whenever a message is sent inside of Telegram, there needs to be a webhook. And for that, we're using route handlers inside of Next.js. This is a post request, and this is the code for setting up the Telegram bot. It's honestly pretty straightforward, but this is just the setup code. The next code, the function that it points to is handle Telegram message. And this is where the fun begins. Like I said, we have the logging layer. So we're going to log everything and log all the steps inside of Supabase, which is our database where we are storing everything. We are also going to load the conversation history so that the agent has access to previous history. And then this is where we are going to run the agentic loop that we talked about. Now, think of this agentic loop as the master orchestrator. These tools are different minions that have specific tasks, they have specific prompts, and they know exactly what to perform. So now, one question you may have is, well, this master orchestrator makes sense, but why are we using an outdated model? Now, here's the thing. In my case, I think I don't need to use the latest models and burn a lot of API tokens. I'm okay with using an older model as a decent enough job for me for the tasks that I want to perform. So I'm going to use this. It costs me less, so cost is very important in my case. How much does this cost you? Honestly, per week, it's been costing me about $3, like $3. but I have loaded a $25 credit in my Anthropic API key. And this way I can monitor it. I don't have the auto reload option on because that scares me. So for now, it's $25. And once you load it, you have it, then you can monitor and assess what's taking longer, if you should be using more stuff, and so on. Make sure you use a model that makes sense for you. Then we have the system prompt. This is the master orchestrator system prompt, and you can already see you are Kobe. Kobe is the name of my dog and also a name of this helpful AI assistant. And these are the guidelines for it. You're not just a general chatbot, such as you have tools to manage students, check revenue, process refunds, use them in apps, and monitor the course website. So now, once we have access to the system prompt, now there's course tools, and this is where the fun begins. Now again, like I said, master orchestrator, and then these little minions that are going to run. These course tools are that. Now this needs to follow Anthropic Claude Agent SDK Anthropic tool type. So that's very important. What is a description and a schema? Again, adding more constraints so you don't have to do anything bad. These are all the different tools. But the one that I think would be very interesting to look at is check course freshness, which we have been. Check course freshness has some specific code. Now this is the function that it runs. So whenever Claude picks a tool, this is the function it's going to pick. Now, once we get in here, since we're using the Claude Agent SDK, we're using the Agent SDK from Anthropic. The reason why I'm using this Agent SDK is because it autonomously reads files, runs commands, searches the web, edits the code, and more. Now, a lot of these Agent SDKs out there, they don't necessarily search the web, and they cannot necessarily perform all the tasks that Agent SDK does. So that has been a game changer for me, such as it has access to Bash, which could be a allowed tool as well. So Agent can perform a lot more cool stuff. That's what I'm using here. You can see specific instructions for where the code is, and it's going to take a look at my code base. It's going to also take a look at web, and you know how it knows? Because it has this web fetch tool, which is an allowed tool from Claude that will let it web fetch it and check the latest Next.js docs and compare that and see if my course modules are up to date or not. Now again, this is very cool because I've been using this constantly, and this is an example for it. So you can see how certain content was updated and which send me a good summary. So going back to course tools, we have course freshness as one of the tools, right? But these are all the different tools as well, and every single tool has access to my systems, and then it performs specific tasks as well. Now, I've hard-coded some of them just because for this specific demo, but you can see how this entire system is built. Build one for yourself as well. As you can see, the content auditor, as I was trying to build it, its job was to check the course lessons against the latest Next.js release and tell me what's outdated, read-only stuff, which is great. But I wanted to take a step further, and I wanted the agent to also be able to suggest schema changes when Next.js shipped something that affected my course database, like a new way to handle sessions or a caching field that needs to be added. So I gave it a new tool called as run migration. It does not exist right now. There's a reason for that. The idea was that the agent could draft a migration, I would review it, I would approve it, and it would run. Except I did not wire the approval step yet. I was going to do that next. And I just wanted to see if the agent could even draft a reasonable migration first. I asked it a simple question. Are there any schema improvements that I could make based on Next.js 16? And the agent went off, it read my schema, read the changelog. It decided on its own that my old session table was deprecated and that it drafted a migration to drop it. Then it called run migration because I gave it the tool with no approval gate. Now, the only reason why my database is still here is that I had an agent running in a terminal where I review every tool call before it executes as I was building this orchestrator overall. And I hit no in my phone because it asked me for approval. Like, hey, do you want to do this? And that's when I was stressing out because it was too much. If I wired up the auto execute path, I was planning on the next day. Again, if I had stepped away to make coffee, the session table would have probably been gone. Every active login, every student in the middle of a lesson gone. And I have backup, but I did not have backup for up until like live data. It backs up every day. So again, here's what I got wrong. 3 things. 1, the agent was using my database role. Same permissions as me. That means admin permissions. We don't want that. What this means is it can do anything. It could drop tables. It could migrate data and so on. We don't want that. So 2, I added a destructive tool before I added approval gateway. You have to remember, you cannot just add something destructive just like that because these agents are very powerful with so many of these tools available. So you don't get to ship destructive tools and add the safety later. Safety has to ship first. 3, even when you're building it, even when you're brainstorming it, you have to be a little bit more on top of it because security is very important. Number 3, I tested the agent to know what was destructive. It didn't. To Claude, run migration is just a tool. It doesn't have the concept of, oh, this one is scary. That's my job, not the model's job. So I burned it down completely, the whole architecture, and I rebuilt what I just showed you with one rule. The database itself has to enforce the leash not my application code, not my prompts, the database. So even if the agent tries to do something, I can set specific permissions on the database level to do so. So here's what I did. We have Telegram conversations, agent log, approval queue, but more importantly, agents can insert and read its logs and a policy for what it can or cannot do. It cannot update requests, it cannot delete requests, what it can or cannot do, and has a row level security here as well. Insert pending only and select, but never update. Things like that really help me to add those necessary guardrails in place so that agents can perform in the boundaries that I have set them to have versus going rogue and doing whatever they want, which is not what we want here. So how much can the agent access? Well, if destructive action should require an approval, take backups frequently before any agent triggers. This way you have the latest data. Scope permissions, that is allowed tools only. The array, make sure to review what the agent is allowed and not allowed. Very important. Rate limits. So if, for example, I said max turn is going to be 15, cap it at 15 or less than that and see if your agent can perform its tasks or not, how much it hallucinates. But rate limiting tool calls will also prevent any unnecessary issues. And lastly, log every action so you can view history. Now, I did have logging in place inside of Supabase earlier, but I added more logging. So not just what the agent is doing, but also step by step exactly what the agent is performing. For example, over here, like these are conversations, but agent logs, these are the different steps that the agent is taking. How many loops did it go through? What are some approvals that we need to go through, and so on. Again, all of these are very important whenever you're creating agents and so on. So this is just a quick summary of what broke and how I fixed it. And you can then assess how you want to build these agents. The best agent is the one that ships. So you want to start small. I did not just come up with this entire architecture from day one. This has been months in the making. And I wanted to sort of show you in this video, like how I went about doing it and what are the tools I use to do so as well. So start small, go with one task, with one tool, one feedback loop, and then iterate and move on and do better. So that's all for this specific video. If you want me to create a deep dive on how I went about building this entire agent, and you want me to open source the code as well as part of it, then comment below and let me know if that's what you want me to do next, and I will work on creating a video. But thank you so much for watching. Make sure to check out Supabase. There's a link in the description below, or you just let them know that you came through me, and that would be very much appreciated as well. So thank you so much for watching. Bye for now.